we need to look today at the ions that are formed by different elements in the periodic table. And we're going to use this information when we're talking about or predicting the formulas of compounds that the different elements form. And what you can see from this partial periodic table that I have is that different ions tend to form different elements tend to form ions with specific charges, and there is sort of a pattern to the charges that are formed. For instance, everything in the first column tends to form an ion with a +1 charge. Everything in the second column tends to form an ion with a +2 charge. Looking at the other end of the periodic table, I've actually left off the noble gases because they don't tend to form ions at all. They tend to stay as monoatomic atoms without forming ions. In the seventh row, 1 over from the noble gases, you tend to get a -1 charge. 2 over from the noble gases, you tend to get a -2 charge. 3 over, you tend to get a -3 charge. A couple of other things that you need to be aware of when talking about the preferred charge. We also call this the oxidation state of these elements. Iron and a few other transition metals form species with several different possible oxidation states. In other words, sometimes iron would be in a compound with a +2 oxidation state. Sometimes it'll have +3. Cobalt will be either +2 or +3. Copper +1 or +2. Both tin and lead +2 and +4. Mercury is +1 or +2. And gold is +1 or +3. And you do need to memorize these. In fact, you need to know the oxidation states of all of the ions shown here. So if, for instance, you're asked what's the most common oxidation state of strontium, you can look and say or you don't have to look, you can say automatically that it's +2, knowing that simply from its position on the periodic table. We're going to use this, and I'll talk more about this later, in predicting the oxidation state of elements in compounds. For instance, if we had the compound Fe2O3 and we wanted to know the oxidation state of iron, we know that oxygen is always going to be -2 in 99% of the compounds we look at. So 3 times -2 equals -6. So in order for this to be a neutral compound, the two irons have to add up to +6, which means that each iron is +3. As I said, we'll look at more examples of this in other presentations.